In this video, we're going to be looking at how we can use the law of cosines to solve a triangle in which we are given two side lengths and the measure of the included angle, which is what we see here in this example that we'll be doing momentarily. But first, let's talk about the law of cosines. The law of cosines, as is stated above, says for any triangle ABC, as is shown, the length of side C squared is equal to the lengths of A squared plus B squared minus 2 times the product of the length of segment A times the length of segment B times the cosine of angle C. Now, a couple of things that are important to note here. First of all, in your triangle, whenever we name the vertices A, B, and C, it's important to understand that side A is always opposite angle A, side B is opposite angle B, and side C is opposite angle C. If you were to change the letters or the names of these vertices, then you'd have to change the corresponding side lengths in the same way. Another thing that we have to keep track of, here this is all a product, 2 times A times B times the cosine of angle C. And because that's a product, that's going to come into play a little bit later whenever we start trying to find missing angle measures. We'll talk about that more in a minute. A third thing that we have to recognize, whatever letter we start with here, remember this is a side length, the angle that's opposite it must be at the other end in the equation. So the cosine of angle C on one side means side length C is on the other side. So these must be opposite each other. And you'll see why that's important in just a moment. Likewise, the other two sides of the triangle, which in this case would be sides A and B, here, here, there, and there, those are the sides adjacent to angle C. And that's always going to be the case. Now, why is that important? Because you're not always going to be given angle C's measure. Like in the case of this example here, we can see that the measure of angle B is given, which means we need to be able to rearrange the portions of this formula to accommodate other angles besides C. So for example, let's say that I'm given, as I am here, the measure of angle B. Then if I'm going to have an angle B on this side of the equation, I have to have side B on this side. So this would become B squared equals, now in these positions where we have the A squared plus B squared, those are going to become the other two sides. So not B squared now, A squared plus C squared minus, now in our product, 2AB is replaced with 2 times A times C, which are the product of these two, times the cosine of angle B. And there again, these two are opposite one another in the diagram, and these are the sides adjacent to angle B. Likewise, we could also be given the measure of angle A. If we were talking about cosine of angle A on this end, then we'd have to start with A squared on the other side. And we have the sum of the other two sides squared, so B squared plus C squared minus 2BC cosine of angle A. Now, granted, not every triangle is going to have vertices A, B, and C, which means as you change the letters in the triangle to represent different triangle names, then you're going to be changing these relationships accordingly to reflect what information is given or what information it is that you're trying to find. Now, when it comes to solving a triangle in the case of side angle side, which is what we're specifically looking at here, you're actually going to be using two different forms of this equation to find some unknown measures. All right, so in our example, we are given, in triangle ABC, the measure of angle B is 81 degrees, the length of side A, and remember that's opposite angle A, is 22, and the length of side C is 19. And we can see that that is a side angle side relationship, which is why the law of cosines would be appropriate. Okay, so the first thing that we want to do is determine which of these three versions of that equation do we want to use, and you're going to base that for side angle side off of which angle you're given. So in this case, we're given the measure of angle B, which means this form of the equation that starts with B squared is going to be the most appropriate one to start with here. Okay, so I'm just going to copy down that formula. Now that we have the formula written, we can go ahead and substitute into it. In this case, everything that we are given lies on the right side of this equation. We don't know the length of side B, so we'll leave that as a variable. A squared becomes 22 squared plus C squared, which is 19 squared, minus 2 times, and remember we said this is all a product, 2 times 22 times 19 times the cosine of 81 degrees. And as I said, every number that we were given in the problem is represented on the right side of the equation, which means in this case to solve for the value of that variable means that we want to first input all of this into our calculator, and we're going to do that just as it appears on the page. So 22 squared plus 19 squared minus 2 times 22 times 19 times the cosine of 81. Now, you should, in this case, get an answer of 714.22, etc. And of course, we're going to have to round that because that's not a rational number that we can change into a fraction. If you get a number different than that, my advice is check to make sure you're in the correct mode. And here with the TI-84, you can press the mode button and see that I am, in fact, in degree mode. If you're not in degree mode, if you're in radian mode, you'll get a different answer than this 714.22. Okay, so that represents the length of b squared. Now to get b by itself, which represents the length of that unknown segment, then we need to take the square root of both sides. Now here to do that, I'm going to do second square root to get that square root symbol pulled up. And I want to use the previous answer. So in the case of my TI, that means I'm going to press second and then the negative key. And you can see right above the negative key it has ANS written, which means it's going to take the previous answer. Notice on the screen it says that ANS as well, but it's going to take all of these decimal positions and put them inside that square root. So in this case, we get a value for b of 26.72. Now that is a rounded answer, and I know typically math teachers will tell you to don't round until the very end, which is why I tried to use that second answer function. But here's the situation. With this law of cosines, what you're going to find in the next step, we've now determined the length of segment B is 26.72. But what we're also asked to find when we're asked to solve the triangle are these two unknown angle measures, the measure of angle A and the measure of angle C. To find those, you're going to need one of these other variations of this law of cosines. To do that, you're going to need to use, depending on which one we choose here, either one of them is going to require us to use the length of B in place of b in the equation. We're going to go ahead and use that rounded value. It's not going to make a huge amount of difference in our answers, and you'll be given some leeway as far as rounding is concerned anyway. Okay, so to find a missing angle measure then with the law of cosines, the first thing you'll want to do is just pick one of the equations to start with. We've already used this b squared equation, so I don't want to use it again because I won't get anything new from it. So you get to choose which of these two you want to use. And I'm going to choose to use this bottom one, a squared equals, etc. It is just a matter of choice. Either form would work. So a squared equals b squared plus c squared minus 2bc times the cosine of angle A. All right, so let's substitute in what we know in this case. We know A is 22. B we found to be 26.72. That gets squared. Plus C squared, which is 19 squared, minus 2 times 26.72 times 19 times the cosine of angle A. Okay, so solving an equation of this type, there are some common mistakes that people tend to make. It's important to realize that this is a constant number. It has one specific value. In this case, 22 squared is 484. Likewise, this 26.72 squared is also a constant. There's no variable attached. The 19 is a constant when we square it. But this 26.72 and 19, all of those numbers are part of this product, which means they don't represent a constant. They represent a coefficient on this trigonometric expression. So what you'll want to do whenever you solve these equations, you're going to go through the order of operations. Simplify anything in parentheses or grouping symbols. We don't have anything there to do. Second step, do your exponents. So I've gone ahead and squared that 22. Let's do the same with this 26.72, which gives us 713.9584. The other exponent is that 19 squared, which gives us 361. And now we have no other exponents to do. Okay, so that takes care of the parentheses and exponents part of the order of operations. Next in the order of operations says multiply and divide going left to right. So the only place that we see any multiplication and division in this case would be here with this 2 times 26.72 times 19. We know that that is also being multiplied by the cosine of the angle A, but for now we're just be able to multiply these values together. We're going to leave everything else the way it is. So here we'd have this 484 equals 713, etc. And after that minus sign, now we have 1015.36 times cosine of angle A. Okay, so we've gone through grouping symbols, exponents, multiply and divide, which leaves us with addition and subtraction. And this is a place where people tend to make a mistake. I want you to take a side journey with me here for a moment. Let's assume that we have an equation 7 equals 2 plus 3 minus 5y. If you were asked to solve that equation for y, the first thing that you would do is combine these like terms 2 and 3. We know, because of what we know about solving equations, that we cannot combine the 2 and the 3 with the negative 5, because these are what we call constants, and this is a coefficient on y. So here our process would be to combine the 2 and the 3, combine those like terms, and get something along those lines. That's the same thing that we need to do here. Combine your constants, which is going to be these two values, but we cannot include that minus because the minus actually represents part of a product, so that 1015.36 is a coefficient. All right, so we end up with 484 equals 713.9584 plus 361, and we get a value of 1074.9584. And this minus, etc., it's going to stay just the way it was. Okay, so let's kind of continue on with our analogy here. If we were solving this for y, the next thing we need to do is move this constant term to the other side by subtracting it on both sides. So we would have subtracted 5, which would have produced 2 equals negative 5y in that scenario. It's the same situation here. We want to subtract this 1074, etc., from both sides. So when we subtract 1074.9584 from 484, we end up with negative 590.9584. Keep in mind this negative is still attached to that product that we have remaining. Okay, next thing that we'll need to do here in our scenario, we divide by negative 5. In this case, we're dividing by this coefficient. So when we divide on both sides by that negative 1015.36, on the right, we'll be left with the cosine of angle A. On the left, we get a value that we have to round, 0.582 approximately. Okay, so now to get the measure of angle A means getting rid of that cosine that's attached to that angle. And we know that the way that we do that is by using an inverse cosine on both sides. So here we apply the inverse cosine to this decimal, and we apply it on the right. Now on the right, when we take the inverse cosine and apply it to the cosine, those cancel, which is going to leave us with the measure of angle A on that side. And on the other side, we press our second cosine, and we're going to use the previous answer again. And in this case, we get a measure of approximately 54.4 degrees. Okay, so we found two of the three pieces that were unknown. Now to find that third angle measure, the easiest way to do that, you could go back to the law of cosines and do the other third form, the one that starts with b squared, but honestly it's simpler and quicker to just go with the triangle sum theorem. We know that all three angles have to total 180 degrees, so we take 180, we're going to subtract this 81 that we were given, and subtract the 54.4 that we found for the measure of angle A, and that tells us that the measure of angle C must then be 44.6 degrees. And that's the process then that you would use if you were solving a triangle in which you were given two side lengths and the included angle measure.